Okay, so I'm Cale Hoopes. I drove over the mountains to get here, yeah, that's true. I actually work for this company called InVision. I'll talk about that in a second, but I live over in Lebanon, so, and work remotely full time. So that's actually really cool, and I'll talk about that in just a second. But today I'm here to talk about middleware. I don't know how much middleware topics you've had experience with, so don't feel patronized if I talk about basics or if I talk about advanced. I don't know, honestly. I've only been doing Go professionally for about 3 months, which isn't very long, but have been an enthusiast in Go for a little while. So I want to talk about InVision first, because a lot of people don't know about InVision. I didn't know about InVision until I ran into it at my former company, Capital One. InVision is a design collaboration company. We build tools so that designers in enterprise companies, or even not in enterprise companies, can share things like artifacts, like graphics, style guides. They can build storyboards together just on the web. So this is a good example of some of the stuff that we do. This is like prototype. We build software so you can go on there and build Android, iOS, and web prototypes. And it's pretty cool. It's drag and drop. The components actually work. And then we also have a mobile app where you can download those prototypes and actually interact with them like they're real apps. But ultimately, there's no backend to those or data. It's really just canned Lorem Ipsum style data or whatever you put into the app. But it's actually pretty cool to be able to visualize your stuff. And then you can actually take that stuff. We have an engagement with a company called user testing. And you can take that stuff and actually put it in front of users, test it in front of users, and see what those users interact with. We also have a lot of other things that we're working on that make the design experience even more fun by putting plugins into like Photoshop and interacting directly with Sketch, so that you can, so the designer could just do all of this work in Photoshop and get all of that stuff into the InVision product, and then interact with annotations and communication between designers. So the thing that got me to InVision and why I wanted to talk about it a little bit is, one, we're on a journey in Golang. We're trying to sort of look at our back end and look at the ways that we could use Golang as a competitive advantage to improve our APIs and our platforms. So that was one of the things that jumped out at me. And the other thing that jumped out at me is it's a fully remote company. Everybody in the company works remote. We do not have an office that people come into. We have people in Brazil. We have people in Czech Republic. We have people in France, and a bunch of people on the East Coast, and a bunch of people on the West Coast. And what that does is it means everybody has to work remote, and everybody has to communicate all the time. So we use tools like Slack and Zoom and Google Hangouts. And I've never been in a company with such a great culture. I mean, it's just a great experience. So, okay, that's InVision. But I want to talk about that a little bit because most people don't know about InVision. We're a small startup. We're growing. We have about 250 people now, and we're looking for people. So there's my plug. So let's talk about middleware for a second. To give you a little bit of background, I come from a C# background and a Java background. I spent a lot of years playing with ISAPI filters. I spent years with HTTP modules and the ASP.NET pipeline, where one method to the next method to page load and all sorts of pipelining. And so when I first got into Golang, I quickly ran into this. Okay, so I can set up an HTTP handler, now what? Okay, so I get a request, I get a response, and I output something from the response. So I started looking into middleware, and I wanted to talk about this a little bit. It's hard for me to see my slides. Just a second, I'm going to come back here. So middleware, when you think about middleware, if you came from software development, for a long time middleware is sort of what we talked about when we talked about hardware to software communication. for a long time, and then it transitioned in the SOAP years and the SOA years to talk about middle tiers. Middleware was like, okay, that team's going to write the middleware between the website and the database, and we're going to call it middleware. And so for a while, that term was used. Where I really ran into it as a concept, as a new concept, is when I started doing some JavaScript development. And if you've done any JavaScript development, you run into Express. And Express has this idea that you can set up these routes, and you can set up middlewares, which are basically functions that receive request and response. And then you can have these functions chained together to do things every time a request comes in. So I put together this diagram over here. So in this diagram, so you get a request. Usually in middlewares, you get a request and then you'll get some kind of write. So in most of the Golang middleware projects I'm going to show, that's the truth. You get access to both these things. And then this is the concept around it, is every request I might want to do something like accept cross-origin requests, like for an API request from a browser. Or I might want to check an access token. This is a really common thing with like open APIs. And I might actually want to log the route because automatically Golang's not going to log the route for you. It's just going to say, hey, whatever you want to write in your HTTP handler, you just write that. And then at the end of the day, you're going to do your stuff, whatever it is. Go to the database, get the customer information, and the customer information back. So the way that I think about this, I found this great definition. A function in the HTTP pipeline with access to the request and response. And that's the core of it. Okay. There's a lot of ways of thinking of it. The approaches, pipelines, where it's like this thing, and then the next thing, and then the next thing. There's also this idea of wrapping. This thing wraps the next thing, which wraps the next thing. And then there's this idea of chaining, where it's like this thing calls the next thing, and calls the next thing, and calls the next thing. So you have these three different approaches. So one of the things we did at InVision is we came up with our own library. I'm going to talk about that in a minute. But we did go through and look at some of the libraries out there. We found good things. We found things that we wanted to change about them. And we didn't necessarily want to change those projects. So I'm going to go through three of those real quick. One of the projects is Negroni. This is probably, I would say it's probably one of the most popular middleware solutions for Golang. It's pretty clean. So let me talk about it for a second here. I'm going to turn this so I can actually see. First off, there are some middleware packages inside of some of the Golang web libraries that come along with the library, meaning I've got to implement this entire web services framework, and then I get this feature called middleware. I shied away from those things because I don't like to get fully dedicated to one big framework and then be, tied in with that. So Negroni is a good one because we're talking about a simple library. It has a really familiar API, and I say it's familiar because the idea behind Negroni is that you set up a chain of middlewares and then you use this use function. You can do either of these approaches. This is really similar to Express. In Express, there's a use function, and you can set up as many middlewares as you want. Then you can set up your routes, and then you can do your listening, your HTTP listening. So anybody who's coming from Express is going to look at Negroni and go, well, I get it. It totally makes sense. On the other hand, one of the things that we sort of didn't like about Negroni and why we didn't use it is because setting up route-specific middleware can be kind of confusing and challenging with Negroni. And it's really about, depending on what kind of handler stuff that you have to do, and there's some specific wrapping. Some of that stuff was a little, we didn't want to go there. But Negroni works great, and there's no reason to just dismiss it for sure. The other thing that's interesting about Negroni is the way that they implement the middleware. The way that you have to write your middleware functions is to set up an object that implements this handler interface. So the serve HTTP method, and you'll see it looks kind of like an HTTP handler in that there's a request and a response writer, although they did swap them. I don't know why. But then you also see that another function is bound to that. So the way that this chains together is this middleware that you're getting here is the implementation of it is response writer and request, and then this next function is going to get passed to it. So basically, when you see the implementation of this, you see here's the method signature, here's the internals of what the middleware does, and here's the call to the next function. And so it uses this next here to make it call to the next function. So it's basically just a chain of methods. So we looked at this. This is like I said, a pretty popular library. We looked at this and we decided to try it and we played with it, but we eventually moved on. The next one I'm going to talk about is called Interpose. This one I found, and I bring it up because it has a different approach, a really intriguing different approach. Basically, it's just another library, so it's not a full functioning framework. So I'm not tied into sort of their big framework that tells me how to do routing and how to do all the other things. It's just middleware. It's a nesting of middlewares. So instead of my middleware calls the next function, which calls the next function, which calls the next function, they basically set up a collection of the methods, and then they call them in kind of an interesting order. So I added this comment directly from their readme, and I found it was really interesting because basically, when you go in here and you add, let's see, did I put this in here? I did. So when you add middlewares, you'll add like middleware 1, middleware 2, and middleware 3. The way that the handler is going to call, it's going to call 3 first, then it's going to call 2, then it's going to call 1 in a reverse order, which is kind of an interesting approach. And honestly, I can't noodle my brain around it.
That's how Java filters.
Yeah. So anyways, this was an intriguing one. This one had a lot of stars on GitHub. I think it gets some use, and it's a different approach to middleware than Negroni. And I think that's why it sort of stands out. There are a bunch in the Awesome Go list that look like the variations of Negroni. They're just like small variations of Negroni. So I put the code over here to sort of show the example. The example was sort of hard for me to follow at first when I looked at it. But basically, you just new up Interpose to this middle. You create a handler. It looks like a regular HTTP handler function. This actually is an advantage over Negroni, because Negroni you actually have to implement the interface. So they have a special interface with that next that you have to implement. If you don't implement that, you can't be a middleware. So this kind of is nice because it'll use any handler function as a middleware function. So that's kind of an advantage. The other part of it is this, you can use any MUX. Here you can use Gorilla. I believe this is Gorilla as a router. So it's a pretty straightforward library. It looked pretty small. When I looked at the code was actually tiny for what they do, but honestly the code was basically a map of functions that fired in reverse order. So that's what I got out of that. I'm going to share this presentation, by the way, with the links to all of these things. So I'll send that out. Okay, so Alice. Alice is an interesting one, and it's a very, very popular middleware for Golang. The reason Alice is so popular is because it is really bloody simple. It's a very tiny library that basically takes the way you write middleware on your own without a library and makes it syntactically a little easier to set up. To walk you through this, I put like his whole example here because it's small enough that you can just add it. He's got an example where he's created a timeout handler and he's pulled in a throttle handler. So the other thing about all of these middleware libraries is there's some canned functionality that you get with each one of them. So Negroni has a long list of middlewares that third parties have created for doing everything from accepting cores to JWT translation to special logging, different logging libraries. There's all sorts of things that are built out. Alice doesn't really have those, but because Alice supports regular HTTP handler right out of the Go library, it'll support just about any middleware you want to set up. So Throttled is one of those, where they basically create an HTTP handler for throttling requests, and then you can set that handler up, then you can add it. This is actually creating this app. So this is the app, Hello World, right? And then what you do is you create a chain with Alice. You can add your throttler, your timeout handler, and this no-surf new peer. I can't remember what this library does. And then finally, your handler shows up in here, which is this. This is your app. So what you're getting is throttling, timeout handling, and like I said, I can't remember what this is. And then the chain basically just gets passed into the listening server. So it's a really easy way to set up your middleware. And it's pretty nice. We did consider Alice, but we wanted something a little bit more. Let me see, did I miss anything here? This is definitely the smallest library. I'd say if you're going to build your own, it probably wouldn't hurt to fork this and build your own off of it, because it has a lot of space in it for updates, changes, anything that you might need to do custom. Okay. So that gets us to make your own. What's it look like if I'm just going to make my own? So there's a lot of questions, and I threw them all out here. So a lot of times, we're not talking about a dev building a website. We're talking about a corporation that has a team of developers who are working on an API or working on a specific thing. And so what might happen is you might need to build this to facilitate standards across your organization. You might want to build, this is how we do middleware at so-and-so company, Taco Cat company. Just to nod at that. And so that might be a good reason to say, Negroni's not going to work for us because I have something else to do. The other two could be too cumbersome. I don't want to fork Alice. I want to build something from the ground up. So I got this example, which is pretty simple. And basically, you can build HTTP handlers to do stuff. You can have a final handler. Think of this as, okay, this is probably where I'm going to call my database and get my customer information. But this might be a logger, or this might be, I want to confirm a JWT, or something like that. And ultimately, middleware in Go is super simple to write if you don't have anything special you need to do. You set up your handler as a handler function. You handle the route. In this case, it's just slash. And you can see, I just got a function. It's calling another function. It's passing the handler. So basically what happens is this gets passed to this, which gets passed to that. They all execute in order. You got middleware. It's pretty simple. So when you go back and look at Alice, back here, this is really the same functionality as what I just wrote there. This is just syntactically a little easier to write. Because it's not method calls method. It's really just this, comma, that, comma, and dot then. So in a way, Alice is just helping you do something that you could do for yourself. All right, all that's to say, you might have a reason to make your own middleware. Go for it. You'll learn a lot. There's a lot to be learned in the space, for sure. And I got links to this article that I use as reference. Okay, so that brings us to Rye. So at InVision, we started by building out one API project, and that API project was going to be pretty important to InVision. It was going to be our authentication, our new authentication approach, which was going to use a JWT approach. With that, we found there was a bunch of things we needed to do, and those were going to have to be middleware. Additionally, one of the things that we really worried about was being able to monitor services and being able to get good metrics out of the services. And so what happened is we built a service and we built a bunch of middleware and we built an approach for it, and then we realized, wow, the next service that we built, we ended up copy-pasting a lot of stuff. And so we're like, well, maybe this needs to become more than just in that project. Maybe we need to grow it past that. So that's where we came up with Rye. So Rye is another approach to middleware. Pretty easy to configure. We put StatsD statistic metrics in there. So every time a middleware gets called, we record a stat for timing, and we record a stat for counting, and we record a stat if there was an error. So that was kind of a neat function that we thought we would grow. We decided that we were going to be 1.7, and that's it. We weren't going to make our library backwards compatible, so we support context out of the box. So when you create a request, you get a context created for you. You can add stuff to it. I'll give you an example of that in a little bit. We also created a bunch of out-of-the-box middlewares that we use all the time. We have an access token. We use CIDR verification. That's to control IP addresses that can hit your service. We also do JWT verification, and we use the context to add JWT into the request, so you can get back to the JWT. We do core support, and that's pretty configurable, and we do basic route logging. All right, so let's get into this real quick. So setting up a Rye middleware is really okay. So setting up the Rye middleware, it's a little more than some of the other middleware libraries. Like you saw the I can't remember the second library that I talked about, Inter something. But you saw it was just a new. Yeah, Interpose. I don't know what, my brain's broken when it comes to that library. So Interpose was pretty easy to set up. Rye's a little harder. So, and the reason why we made it a little harder is we added this optional StatsD capability. So you can set up a StatsD client with some basic stuff here, and then we have this simple struct that you pass in for configuration, and that takes the client. I'll show a little more about this in a bit. But setting up is basically you set up this middleware handler, and that's the overall handler that's going to chain the middlewares together. Okay. So making a handler, we took a little bit of a different approach. We're sort of like somewhere between, it looks just like an HTTP function in Go, but it has a different output. And I'll give some reasoning why. So we created an actual type, a handler type. And that handler type just takes a response writer and a request. But we have this special response that we output. And what we use that special response for is we allow you to add status codes and error messages to the output of your middleware. This makes it so we can do some special processing with the StatsD stuff, and it also makes it so we can format good JSON error messages out to your client. So we really built this more for API development and less for standard web development where you might take a template and create some HTML. Although I will say that I've done some of that with the Rye library. So then this is some examples of basic handlers that you write. So really all we're doing here is a handler looks like an HTTP handler. We can write to the response. We can do some logging if we want. Returning nil just says that we don't have an error, or we don't want to send a response code with this specific output. If we don't send a response code, it's going to assume 200 and just pass that back to the client. Here's an example. This is just another middleware handler. This down here, here's an error handler. In this case, we're sending an internal service error, and we're setting up a standard Golang error and passing that. Let me see here. We also have another feature that I didn't show here called stop execution. So in one of these, I can put stop execution, and that'll say don't execute any of the other middlewares. Okay. Let me see. Okay, so this is about the stats. Basically, we wanted to implement this so that we could get lots of statistics on what our APIs were doing. When we're a consumer of Datadog, we use Datadog. We use StatsD and we use Docker containers to pull logs off. But these statistics get sent through FluentD, I think, and end up, not FluentD, they get sent through the Datadog agent by a sidecar container up to Datadog. So basically, what we did by tightly coupling StatsD to the RAI library is we made it so every single middleware call in our API stack ends up as statistics in Datadog. And we can then build charts off that. And that is actually really, really useful to us. My examples here, this is our login handler. And what you're seeing here is I have statistics for 200, 400, and 401s, and they just get logged every time something gets hit. Now, it doesn't look like very much traffic because we're not really fully in production with this service yet. But in Datadog, the stats just automatically get delivered to Datadog, and then you can just look those stats up and configure them. In our case, we have this prefix that talks about what cluster we're in, but right here you see this handlers.loginhandler.2xs. It's really hard to see, especially if you're back there. But basically, these stats just get pushed into Datadog, and I can create reports on them really quickly. I know that StatsD is supported in some of the other metric monitoring solutions out there, so this is one of the things that we really thought was valuable for RAI. So I just want to walk you through some of our canned middlewares. The first one is we have an access token. It's easily configurable. Basically, you can configure what header name. So if you have a custom header name, that's pretty easy. It takes a string of tokens, so you can have a bunch of tokens. You can pull those from a config file, from a database, however you want to manage your tokens. And then this is an example of setting up a handler with the access token. So basically, you take the middleware handler, you call .handle on this, and then this takes a slice of handlers, which include, in this case, the middleware access token and your handler. So your handler ends up being a middleware at this point. All right. So the next one is cores. So we built a cross-origin middleware so that you can make it easy to call from your browser JavaScript file, basically. So it takes an origin, it takes a method type, and it takes what are accepted headers. Yeah?
Question. You can replace that RAI handler array with a variadic RAI handler, and then you can omit having to do array RAI handler every single time. You can basically
Right. I might be new enough in Go that I have to look at the syntax that you're talking, but we can talk after, right?
Yeah.
Yeah.
Would look like the syntax that tells that.
It would be very similar, yeah. So it would be just arguments living the array RAI handler, do your RAI.handler, ...
Oh, right.
And then you can just throw in, as many handlers as you want.
Right. Oh, yeah, variadic. Okay, now I know what you're talking about.
Yeah.
Okay, cool. We'll look at that. Yeah, it might be another way that we can set it up. So, okay, cool. All right, wait, were you taking a picture? Okay, so we built Cider one because we want to be able to filter our calls by IP address, and so this is the same thing. We're passing in a string slice of ciders, and then it just goes through, and it'll return a 401 if the cider doesn't fit in, or if the IP address doesn't fit into the cider. And I included a link here, which is ugly because it should have been white, but anyways, this talks about the classless interdomain routing, which is cider. It's really good reference. If nothing you get out of my talk, other than that reference, that's a great reference for cider for some of the tools that we set up that does IP address filtering. All right, JWT, this one was great because we built this thing called auth API. It's our authentication. But what we found pretty quickly is our other development teams were building APIs that would call us and get the JWT, but they're like, well, now what do we do with the JWT now that we have it, and how do we process it, deal with it, how do I validate that? Well, everybody was going to have to build out their own validation. So we built out a JWT middleware that would actually go ahead and look at the authorization header, strip the bearer prefix, and then take the JWT, throw it through this library, JWT Go for validation. But then in addition, we added it to the context. And that is pretty cool because then in another middleware or somewhere else in your chain, you can actually just go back, get the JWT, get information out of it, and start processing on that. Because a lot of times you got user ID, you have email address, or something else in the JWT that you want to get access to. So this only takes a shared secret, which is pretty common with JWT processing. So we found great use in this middleware. Route logging, this is really pretty simple one. We built out a route logger, and the code was so little that instead of an example, I just put the actual code to the middleware. So basically, this returns an HTTP function with a response in it. But really, what it's doing is it's using logRS to take the remote address, the method, the URI, and the protocol, and just stick that and log it. And so this is nice because then now you don't have to think about logging at all. So the other thing that I put in this slide that's kind of cool is I showed you how you might stack all of these. Because ultimately you're going to have some kind of API route that you want to be cross-origin, that you want to log, that you want to make sure the right IP addresses are calling, and you want an access token on it. And so you can see, here's the 4 middlewares I showed you before, and then your handler. So it's kind of a nice way, and you can build more and more things in here as you need them. All right. So context. So I didn't give an example about putting things into context, but really my example here is that the context is available in any middleware in RI right off the request. Now, normally when you have an HTTP handler, if you try and access context off the request, if you haven't set up the context in the first place, it's nil. It's not there. So basically RI sets that up for you, whether you want to use it or not. Then you can add things into the context and pull them out in subsequent middleware. So that's kind of the way that you'll pass data from one middleware to the next middleware, if you really need to do that. I find that a lot of times when you're building middlewares, you don't need to do that. That the middlewares are really sort of a specific, like a validation, some kind of check, some kind of way to stop the HTTP pipeline, something like that. But the JWT one was a great place for us to put this in. So the JWT middleware actually adds the JWT right into the context. And then you can take that JWT and you could get maybe get the email address out of it, or the user ID, depending on what is in your JWT, basically in your JWT. So, John. All right. So so that's pretty much it. Basically, why would you use Rye? Well, it's still a pretty tiny library. We tried to build a library that wasn't as big as Negroni, that wasn't a framework, that we could spread around our organization pretty quickly, that potentially we could give back to the community, which is what we're trying to do. You could go in there and read all the code in maybe 20 minutes. Feel free to fork it, feel free to use it, feel free to contribute. We take contributions. That's just going to be through PR, so fork it and then deliver a PR back to the project. Is it better? Well, middleware is one of those things that's kind of it can go any which way. You could build your own. You could use Negroni. You could build your own library. There's a lot of things you can do, and you wouldn't be wrong. You can do it a bunch of different ways, and it would still work for you. So give Rye a chance, or not a chance. Give Rye a try. Look through it. If you see things we can improve, let us know. I appreciate that. Also, if you see patterns in there that you want to use in your own Go code, that's how I get all my patterns. I just go read other people's code. I think it really helps to learn some tricks. So we learned a ton by doing this. We open sourced some projects at InVision, but we really hadn't done it the right way, and we really hadn't pushed on all the things we needed to push on. For example, we really didn't think about the licensing too much, or we didn't really put that much into the README, or we really didn't, we delivered Go code, but we didn't deliver Go docs, or we didn't deliver unit test coverage. So one of the things we did before we open sourced the library is we went through all of those gates. And that's super valuable. Being able to go back to your CTO and getting approval for doing open source is actually, that's a valuable thing that you should push on and figure out how to do it, just to make sure you're legally going the right way. You should figure out, well, what are, when I look at Go programs, or when I look at Go open source projects, what are all the things that are really required to spread this where people are going to think it's legitimate, like having 100% unit test coverage, or having a Go report card that's in the A to A+ range instead of the F, which I actually have a project out there. I think it's a D+ or something like that. And getting your licensing figured out and making sure the company is good with it. If for nothing else, let me encourage you that if you're in a company that hasn't done any open source, but you want to push on it, because just going through and figuring those things out will encourage the community and should grow your brand as well as a company. And then unicorns, because you gotta have unicorns, right? I don't do a presentation about a unicorn, so I figured you should be there. Anyways, so we have an engineering blog. We have a couple of open source projects out there, but we also have Rye. The technology that we do at InVision is great. We're like every other company. We have a big monolith that's written in an older technology called Fusion. And we are slowly but surely moving away from that. We're moving into new technologies pretty quickly. Most of our production stack is running in Kubernetes. We're using Docker really heavily. We don't have everything solved. We're not a 12-factor microservices brilliant company yet. But we're getting there. We're building services in Go. We have a bunch of services in Node. We're starting to build some React things, and we're starting to build some React Redux. And we're pretty much all AWS, so it is a cloud-based company. But I just wanted to say that because if you're looking for someplace doing newer technology, we're heading that direction. And I'm actually surprised that the company's already as far as we are, especially down to Kubernetes and Docker, because it's pretty messy. It can get pretty messy pretty quickly. So. But anyways, that's right.